Welcome to Cloud AIOps Hub, the channel where we break down complex platform engineering concepts into real-world analogies. All right, today we're kicking off a short series all about ECS Blue/Green deployments, and we're starting right at the beginning with the absolute foundation, the setup. By the end of this, you're not just going to grasp the architecture that makes true zero downtime possible. You're going to start thinking about your own deployments in a completely new way. Okay, so first things first, let's dive in by tackling a phrase we all hear and probably use all the time: zero downtime. I want you to really think about that for a second. Are your deployments actually truly zero downtime? I mean, most of us say they are. But if even one of your users sees an error page during a release, a single timeout, a broken image, then it's not. It's just not zero downtime. That one little failure, that's the crack in the whole system. And this gets to the heart of a really crucial idea. Most teams out there, they're just focused on pushing the next version of the code out the door. But very few are actually focused on designing the system that does the deploying. And that difference, right there, that's the leap from a standard DevOps approach to a real platform engineering mindset. So to make this super clear, let's use an analogy that I really love. Imagine you're running a restaurant, but here's the twist. You've got two separate, fully functional kitchens. Okay, think about the traditional way of deploying. It's basically like having to close down your only kitchen just to update your menu or install a new oven. You literally have to stop serving customers. You're losing money. And if you mess up a new recipe, the whole restaurant is down. It's a huge outage. Now, contrast that with the blue/green model. Here, you're running two kitchens at the same time. You never stop serving. There's no lost revenue. And here's the best part. You can safely test all your new dishes in that second kitchen before a single customer even knows it exists. Okay, that's the story. But how do we actually build this? How do we map this whole restaurant idea to our technical reality in AWS? Let's break it down piece by piece. All right, so our restaurant itself, that represents our two identical ECS environments running right next to each other. Kitchen Blue, the one that's live and serving all our happy customers, that maps directly to our Blue AWS load balancer target group. That's our production version. And Kitchen Green, the one we're getting ready in the back, well, that's our green target group, and it's got all our new code. The new recipes and equipment, that's just our new container image and all the new configuration that goes with it. And this part's key. Both kitchens are fully staffed. That means both versions of our app are running at the same time in ECS Fargate. And finally, that little side entrance for the chefs to taste test the new food, that's our dedicated test listener on the load balancer, probably on a port like 8080. And this right here, this is the whole point of the setup. It means your live, stable version never stops serving your users, not for a second. The whole time, the new version can be spun up, tested, and validated completely on its own, with absolutely zero risk to your customers. Now, you don't build this kind of rock-solid infrastructure by clicking around in the AWS console. No way. It's all provisioned as code, and our tool for that is, of course, Terraform. So here's the blueprint, the recipe, if you will. We start with our network, a VPC, and at least two public subnets for high availability. We need our AWS LB, the application load balancer. Then come our two kitchens, the blue and green AWS LB target group. After that, we define our AWS ECS cluster, the AWS ECS task definition that tells Fargate what container to run, and finally, the AWS ECS service to make sure it all stays up and running. So how does this all click together? It's pretty elegant, actually. 1, Terraform builds the entire system from that blueprint we just saw. 2, ECS Fargate gives us the serverless compute to run the containers for both the blue and green versions. And 3, the application load balancer just holds both of those slots, both kitchens, ready for traffic. These three things working together, they create this amazing foundation where the old version never, ever has to stop serving while the new one is being prepped. Okay, let's zoom out for a second. This isn't just about learning a cool new deployment trick. It's really about a fundamental shift in how we think about our jobs as engineers. The real transformation here is that the engineer's role has evolved. It's not about being the person who nervously hits deploy and just hopes for the best. No. We've moved from that high-stress job of pushing code manually to the much higher value role of designing resilient systems that deploy code safely for us. That is the platform engineering mindset. So, we've built our two kitchens. They're both up and running, ready to go. What's next? Well, in the next explainer, we get to the really exciting part, the switch, and the rollback. We're going to show you exactly how we redirect that restaurant's open sign from kitchen blue to kitchen green, and, just as importantly, what happens when we need to switch it back in a split second. That is a wrap on ECS Blue/Green Setup Explained using real-world analogies. If this helped you understand the foundation of Blue/Green in a new way, subscribe to Cloud AIOps Hub for more platform engineering breakdowns. See you in the next one.